later. So you saw this, and let's just quickly recall this, okay? Function call stack. So this is your single thread. You call different functions on it. The thing at the top of the call stack is going to run to completion. It may start a task and then throw it off into a different API, and then put that into a callback queue, and then the event loop was going to put it back into the stack when it's ready to be processed. So how do we optimize multi-threading in JavaScript? We have a single thread, right? That's obvious. We only have one thread, and that's this UI thread. But really, these web APIs that Philip Roberts was talking about, it's also in Node. There's like a Node API. That is your multi-threading thing, because you want to pull things off the function call stack and just put them for the API to handle. So the more things you can get the API to handle, which is a multi-threaded environment, the faster your program is going to execute. At the same time, you need to balance that with getting things off your UI thread stack as fast as possible. Okay. So let's talk about a couple other problems that some of them we're going to discuss, and some of them we're not. But the first one is asynchronous programming is just tougher to reason about in certain ways. This is a really exciting field because, like I keep saying, this is a debatable point. It's kind of like I'm kind of contradicting myself, but I really don't mean to. It's just a very debatable point in that, like, is this the best way to reason about our program? That's more a better statement of what's going on. For example, like, are callbacks the best way we can really implement this, or are promises better? And there's some other stuff like observables. Maybe that's the best way to reason about UI engineering. But one thing is for sure is that, like, this is a complex field that's just growing super rapidly, and you don't need me to tell you that, like, this is, in my opinion, like, one of the fields that's gonna, like, have a lot of research happening in the next couple of years. The second problem is inversion of control, and I'm going to quickly go into what that is. So this is a diagram of a callback function, basically, and you've already implemented this before. So let's just put this into context of how to really read this. So you've already done this with your pseudo Grubhub application, where you send an API request to a certain endpoint, and then you retrieve that, and then you put it onto your view, right? You rendered it below the button. So your application, your JavaScript, right? So that's your main program. So the main program is running, it's running, and then it hits your $.get or your XHR statement, right? But that's ultimately a library function. That's a third party. So jQuery or XHR. And that XHR thing is going to call your callback. And your callback in your Grubhub application was basically stick the data that you got from the GET request and then put it under the button. Now, this is a really tough point to understand, that now this is a really kind of compromising point in your application. It's that you don't have control over what exactly is going to happen, and that you're giving control over to a library function, a third party. Now, you can use jQuery, you can use XHR, because you don't really distrust them. But let's say you were using a third party like PayPal or Stripe or some transaction API. That's a third party. You can't trust that they're not going to call your callback 5, 6, 7 times. If you had like a checkout system and that library function started to like call your callback function like a billion times, what are you going to do about it? You are implicitly placing trust in a third party, and ultimately that makes it very tough for your program to handle all cases. This is a fact. So it's impossible to fully understand how all your functions will work in all cases. This is also, in some ways, kind of like inversion of control, in that like you're giving control over to jQuery to call your callback. So one, you already can't reason about the execution of your program in the future. Now you really can't reason about your execution of program, because like if the library function doesn't run the way it's supposed to, or maybe it's just not documented right, maybe you just didn't handle all the cases, suddenly your program is very erratic, right? It's irrational. And this is a topic that we're going to explore maybe in the next talk, in the next video, and hopefully this is just like a good introduction for you. And basically we're going to see like how do you fix this situation. and you're going to see it in different kind of tools that are available in JavaScript. The last point that I want to touch on is callbacks. On callbacks, right? So what happens if I press the button, right? So if I'm pressing up and down right now, this is a callback is being executed. But what happens if I hit it like multiple times? How the hell do we like reason about somebody hitting our program, our callback like 50, 60, 70 times? And on top of that, what happens if like hitting this changes the state of my application? In this case, it does. If I hit up, then it changes the state of what I can see, and if I hit left, it changes the state of what I see. What happens if I hit them both at the same time, right? Basically, the only reason why this is possible for slides.com to handle that is because we have closures, because each function has its own state. That's what a closure is in this case. You can see like it's kind of genius in the way that they are able to reserve state within a function scope as opposed to a block scope. Because now, based on what happened in my click, you can retain state throughout that click, right? And that's kind of why we have closures. If you have questions on this kind of subtle point, definitely let me know. It's kind of like a harder topic to express, but basically, closures allow us to do what we can do in JavaScript, especially with events, right? Okay. So last part, concurrency versus parallelism. JavaScript is concurrent, right? Because we have a single thread, and basically we're never going to run two tasks at the same time. So when I say JavaScript is concurrent, this was kind of hard for me to wrap my mind around too. But it's basically just saying that you start a function at one point in time, and then you finish it at another point in time. Parallelism is when two tasks are running at the same time. So I hope this diagram helps. But here, in this case, in this on the left-hand side, task 1 is running, and then it's going to stop, and then task 2 is going to run, and then it's going to stop, and task 1 is going to run. Back when we had like single core CPUs, everything was concurrent. So your CPU is just like kind of like handling a billion processes at the same time, but it's just doing it so fast that you kind of think that it's running in parallel, but it's really not. And so if you have questions on that, let me know as well. Okay, so let's talk about what this talk is really all about. Asynchronous programming is about ordering the operations in which the single thread operates. You want to make the order of operations optimal, such that your engine never stops, such that your UI never freezes up, and that's fundamentally what asynchronous programming is about. And we've seen that it's actually good for in other fields besides just UI engineering. So Node, for example, is a perfect example in which suddenly you can see asynchronous programming being very viable. As opposed to saying asynchronous programming is just viable for UI engineering, because of things like Node, you can suddenly see that it's very viable for things that are I/O driven. Things that have a lot of inputs and outputs coming from your keyboard, your mouse, or like people connecting. That's an input event, just like very different kind of paradigm to think about programming.